Welcome back to this lecture on algorithms. In this fifth segment, we will study the insertion sort algorithm that solves the same problem that the bubble sort algorithm is solving. In particular, these two algorithms have the same inputs and outputs. So their header line, the first line in their pseudocode descriptions are the same, except for the name of the procedure. Now, like the bubble sort algorithm, the insertion sort algorithm performs n-1 passes over the elements of the sequence, where n is the size of the sequence. Now, the difference between the two algorithms is what they do inside each pass. Since one of the skills you have to learn or develop in this course is to be able to read pseudocode and trace algorithms, I will just write out the whole pseudocode for this algorithm. I will not go through it in detail line by line. Instead, I'm going to show you a trace of the algorithm on one sample input, and then it will be your job to trace it in detail, instruction by instruction, until you really understand how it works. So the input we're going to trace this algorithm on is the sequence 4, 3, 1, 2, 5. Therefore, n is equal to 5. And here are the elements of the sequence indexed from 0 up. Now, I would like you to please pause the video, grab a pen and paper, and write down the complete and detailed trace of this algorithm. What this means is that for every pass, I want you to write down the values of I as they evolve through this first loop, and the values of k as they change through the second loop, and finally write down the contents of the sequence at the end of each pass. Please come back when you're done and we will discuss this trace. Now, the main idea behind this algorithm is the following. For every pass p, we assume that at the beginning of the pass, the first p elements in the array are already sorted. The pass will consider the next element, the one right after the sorted elements, and will insert that element in its correct position in the already sorted part of the array. So, for p equals 1, we assume that the first element is already in its correct position. The next element to consider is a sub p or a sub 1. This element will be inserted in its correct position within the sorted part of the array, and in particular it will end up in front of the 4. So when you trace the first pass, the value of I starts and ends at 0. The value of k likewise starts and ends at 0, and the element a sub p is inserted at position 0. So the state of the sequence after the first pass is the following. 3 is inserted in front of 4, and the rest of the sequence does not change. Let's look at pass number 2. The first two elements are now sorted. The next element to consider and to insert is the 1 at position 2. 1 is going to get inserted in front of the 3. Again, you should have noticed that the value of I starts and ends at 0. The value of k starts at 0 and ends at 1. And this second pass inserts a sub p, that is the 1, again at position 0, yielding the following state of the sequence. Now, you probably realize that the meaning of I is the position at which the next element is inserted. I will let you think about the meaning of the variable k in this algorithm. Now we start the next pass, p equals 3. Remember, initially the first p elements, in this case the first 3 elements, are assumed to be sorted. The next element, called a sub p, is the 2, and it will get inserted in its correct position in the already sorted portion. In this case, 2 should be inserted between the 1 and the 3. In other words, it should go into position 1 to replace the 3. And that's what the value of I reflects. Notice the value of I starts at 0 and ends at 1, which means 1 will be the insertion point. I'll let you think about again what happens for k. As you probably figured out, this loop is supposed to actually perform the insertions of a sub p into the sequence in its correct position. In this case, the value of k is going to start at 0 and end at 1, and a sub p is inserted at position 1 in this case, yielding the following sequence. Now notice this sequence is already sorted. However, the algorithm does not notice that. It must execute exactly n-1 passes. In this case, 4 passes. So it will perform the next pass, p equals to 4. The first 4 elements are sorted. A sub p is equal to 5. Now what happens in the while loop? The value of I goes from 0 all the way through 4. What that means is a sub p gets to be inserted at position 4, which is already its current position. In this case, the for loop is not executed, so the value of k is irrelevant, and a sub p is inserted at position 4, yielding the final sequence, which is in ascending order. So to summarize this algorithm, for every pass p, this loop is in charge of finding the insertion point for the next element in the sequence, and this loop is in charge of performing the insertion of that element into the correct position within the already sorted sequence. Now, let me emphasize that one of the main skills you're supposed to develop in this lecture is the ability to read pseudocode so well and to become so fluent in pseudocode that you should be able to trace and understand any algorithm I give you, even if I don't describe the behavior or the goal of the algorithm, even if I don't tell you its inputs and outputs, even if I give you a meaningless name that does not indicate what it does. You must be able to take any pseudocode description and trace it, and if you do it on maybe a couple or several instances of the input, you should be able to figure out its behavior. Now that's a pretty tough skill to develop, but this is the expectations that I have in this lecture. So make sure you're comfortable with all of the algorithms in this lecture, and the goal is twofold. One, you should be able to trace this insertion sort algorithm, the bubble sort algorithm, and all of the other algorithms. And second, you should be able, after so much practice, to trace any other pseudocode description of any algorithms that you encounter.